Hey everyone, and welcome. Today, we're jumping right into a really core idea in geometry, congruent triangles. We're going to break down what it means for two triangles to be completely identical, and then we'll explore a super powerful shortcut for proving it. Let's get to it. All right, so let's just kick things off with a simple question. When you're looking at two triangles, how can you be absolutely 100% sure they are the exact same shape and the exact same size? What do we actually need to know to say, yep, these are identical? You know, the basic idea is pretty intuitive. We say they're congruent. And what that really means is if you could just pick one triangle up and place it right on top of the other one, it would be a perfect fit. All the corners would line up, all the sides would line up, no gaps, no overlaps, just a perfect match. Okay, so that's the simple idea, right? But, in geometry, we've got to be a little more precise than just saying it fits perfectly. We need an official language to describe this relationship, and that's where something called a congruent statement comes into play. This is what it looks like in the world of geometry. That first little triangle symbol just means triangle, and that symbol in the middle, that's the big one. It's an equal sign with a little squiggly line on top, and it means is congruent to. So this whole thing reads triangle ABC is congruent to triangle DEF. Simple as that. Now this is absolutely crucial. Seriously, the order of those letters, it means everything. It's not random at all. The best way to think about it is that this statement is like a map or a cheat sheet that tells you exactly how the two triangles line up with each other. So this statement is telling us that the first vertex listed, A, corresponds to the first vertex on the other triangle, D. The second vertex, B, corresponds to E. And you guessed it, the third one, C, corresponds to F. We call these pairs of corresponding vertices. Okay, so why do we care so much about which points match up? Well, it's because that's the key that unlocks everything else. Once you know which vertices correspond, you can figure out exactly which angles and which sides are identical between the two triangles. All right, check out these two triangles here. You're going to see these little markings all over them, these arcs on the angles and little tick marks on the sides. These are just visual clues that geometers use to show us which parts are congruent, or, equal in measure. And here's the rule. It's super simple. Once you know which vertices match up, you automatically know which angles match up. It's a direct connection. So let's go back to our statement. Triangle ABC is congruent to triangle DEF. Well, that tells us right away that angle A has to match angle D, angle B has to match angle E, and angle C has to match angle F. See? The order just gives you the answer every single time. And if you look back at the picture, the markings prove it. See how angle A and angle D both have that one little red arc? And angles C and F both have two arcs, and B and E have three? The picture is telling us the exact same thing the written statement did. And guess what? It works the exact same way for the sides. No surprise there. We can use those same corresponding vertices to figure out which sides are the same length. Let's look at our little roadmap again. Delta ABC congruent to delta DEF. The side made by the first two letters, A and B, well, that's going to match the side made by the other first two letters, D and E. Same deal for the next pair. BC matches EF. And then the outer ones, AC, match DF. It's a really consistent pattern. And yep, the diagram backs this up completely. Side AB and side DE, they each have one tick mark. Sides BC and EF, they have two. And sides AC and DF, they have three. The visual clues and the written statement are telling the exact same story. So when you put all of this together, you get the official textbook definition. For two triangles to be truly congruent, you have to show that all six of their corresponding parts, that's the three angles and the three sides, are congruent. Okay, but hold on. You're probably thinking, whoa, do I really have to check all six of those things every single time? I mean, that sounds like a lot of work just to prove two triangles are the same, right? Is there a faster way? Well, you're in luck because the answer is yes. Geometry gives us some awesome shortcuts. And the first one we're going to talk about is a real game changer, the side-side-side postulate, or SSS for short. So here's the official rule, postulate 12. It basically says that if you can just show that the three sides of one triangle are congruent to the three corresponding sides of another triangle, that's it. You're done. The triangles are congruent. You don't even have to worry about the angles. Just think about how amazing that is. We just cut our work in half. Instead of checking 6 different relationships, SSS tells us we only need to confirm 3, the 3 pairs of sides. If the sides match, the angles are absolutely guaranteed to fall into place. And that's why SSS is such a huge deal in geometry. It gives us this really clean, efficient way to prove things are congruent without having to pull out a ruler and a protractor for every single little piece. It's a powerful tool for building logical arguments. So what SSS really shows us is something kind of profound about triangles. They're incredibly rigid structures. Once you set the lengths of those three sides, the entire triangle, all its angles, its entire shape, is locked in. The angles can't be anything else. So by matching just those three sides, you've matched the whole shebang. Pretty cool, right?